Okay, everyone. Nice to see you here again. And today we will study the chapter 11, and let's deploy all things that we built in all the past chapters. And thanks again, Martin, to stay here with us, and Marceline too. And let's start.
Okay, thank you. So hopefully I should be able to share. Again, please just shout because I'm on a single screen. Not this one, not this one, this one. So today we are going to basically put everything that we built, as Matteo said, so far together, and we will basically try to simulate as much as possible the real production environment. So what we are going to basically start with today, and actually I should say probably that this is like the chapter that will bring the whole Acme car rental together. So it's like more or less the end, but we still have chapter 12 after it, which is a totally optional part where we will basically showcase how to write your own Quarkus extension. Because for some applications or some companies, when you cannot really share the code outside of the company, this can be a use case, and we want to show you how to basically utilize all the goodness that Quarkus can give you in your own applications if you cannot put it to open source. Okay, but back to clouds. So Quarkus applications in the cloud. We have a lot of stuff to cover, and it's impossible to really deploy everything that is in this chapter, which is, I think, like almost 50 pages in 1 hour, just because the internet is not fast enough. So I will purposely be skipping some parts, and I will showcase as much as possible. But like, it's definitely worth the time to sit down with this chapter and to go through it on your own, because really this is more operations. It's not really a development anymore. And like when you are like need to download 17, I think, at the end containers, it will just like take some time. Okay, so this is our final or like semi-final Acme current application. So we have our 5 services, and all of these like smaller ones are just containers which are running and supporting stuff. We have this inventory CLI, but that will be skipped altogether so far, at least in the final deployment, because it's just like a command line application. But you see like the stuff that we use so far, like dev services for Kafka, Postgres, RabbitMQ, etc., Jagger for traces, Grafana, Prometheus for metrics, etc. So I will actually run this because I want to show you. So in this chapter, you have actually a bunch of. So here I have opened the book with a bunch of changes which I had to do today, because unfortunately some parts are no longer working, and I will need to push or force push the repo, because even like how many is it? 10 or 11 months, things will break outside of Quarkus control, but unfortunately, some things also broke inside the Quarkus, which we will probably need to fix, but I will get to it when we will get to it. So we will start in the first section, chapter 11, or let me start from here. So in this directory, you have these Docker Compose files, which is a bunch of Docker Compose files that will basically just bump up the infra. So the first one that we are going to use when we are going to demonstrate the production environment with dev services, which is the first step, is this Docker Compose observability, because back in January there was no LGTM dev service available. So we are basically here just running, and I can probably show you this. We this is unfortunate. I still have some containers running from my testing. That is unfortunate. So I am sorry. I need to kill this because you see that it's up 2 hours. Probably I can do it like this. Because of course, when you are testing, you will forget to remove the services. So hopefully, yeah, now we are clean, because like I don't want to like show you something which is not true. So now we should have only that three services that I was mentioning. So we have Prometheus, Grafana, and and Jagger, which is just really observability stack, which on the previous session, we just used the LGTM stack, which was all included in Grafana hotel image. But for now, we need to run it manually. So now that we have this, what I want to do is basically now do a little housekeeping and go into individual services in this one-on-one and user service and just run Quarkus dev. After this, we'll run, why is this small? Be big. Then I need to do the same is reservation service. This is like just the imitation of the final development environment that you are going to have after finishing all the services. So I purposely want to showcase this with all the, where is it, Docker PS, with all the containers. So we will see them all running together, and we will basically see how much of the work or the infrastructure work Quarkus is taking away from us when we are using dev services. So this is running, so I can do reservation service. I need to purposely wait in reservation service because it needs to connect to the same keycloak in this case as the dev service started by the user service. So it will just start the Postgres and RabbitMQ in this case. Then I need to do rental service, which will start, if I believe, MySQL only. No, MySQL is in inventory. So let me see, because I don't remember which service is using which services. So Mongo and Kafka probably, yes. Then inventory service will do MySQL for sure. And this is too big to see everything, which is unfortunate. So I will need to do a little bit of nicer formatting. Come on. And the last one that I want to run, and sorry, this will be packed today because we have a lot of services to run, but hopefully you will see what I'm typing. If not, just shout. The last one is billing service, which shouldn't start, well, it will start its own Mongo, but otherwise it will connect to RabbitMQ and Kafka started by different services.
I'm looking here, the diagram, and billing service uses Kafka. No.
Yeah, well, we have
And
Kafka there. But it's like this Red Panda container.
Red
This is
Panda.
Kafka. Yeah, this is Kafka because like we talked about that last time, I suppose, because I for sure had to mention it, that in Quarkus we are using this Red Panda container because it's just more lightweight Kafka compatible API. It will start way faster than any other option that we have. So we use it purposely, but you are bringing very good point because actually one of the where is it in rental? No, rental 11.1 and in reservation service, there's some main resources, application properties. This is one of the, no here. Oh, in rental. Come on. I don't remember which service is which main resources application properties. This is actually a very good point. Thank you, Mateus. Because if I didn't mention this last time, this is one of the changes that I had to make, and I need to force push this like soon because I need to just find time. Unfortunately, after the book was released, the Red Panda containers, or like the Red Panda organization, was renamed from originally vectorized to this Red Panda data. So unfortunately, after like 3 months, the book was out. They broke basically the hard-coded Docker image, which is in Quarkus 3.15.1. It is of course fixed now in like I don't remember in which version, but now it's fixed. But this is one of the changes that we needed to include after the book was released because they just renamed the organization. So currently we are just using this Red Panda data, but otherwise, if you would run Quarkus 3.15.1, this would be exactly the same image Docker IO, just vectorized / Red Panda and the same tag. So yeah, Red Panda is in our case Kafka. Otherwise, everything should be matched one-to-one. So if I will now compute how many services we have, the first line is this just header. So we have 10 containers run as basically dev services. You can go to each of these and verify it, like how many of these dev services are running, but you see that it is running more or less a lot of like services on the background. And of course, I'm now counting also these free ones, but currently you have LGTM dev service, which can also run this free. So you will like believe me that dev services can now cover everything that you have in your application. And if I would just upgrade these services to Quarkus 3.31, which is the latest version, and run them in dev mode with the LGTM dev service, I wouldn't need to run any Docker Compose at all or any Docker container manually, which in my case is extremely powerful. So if we will now run this, let me just run a new window, which we will include somewhere here because we have a lot of space to spare. And if I go to localhost 8080, it should correctly take me to redirect me to whatever the Kiko container is. Here I can log in with Alice, and we have some reservation pull up, or sorry, some cars pulled up from inventory service. And now if you will check the terminals, if I click reserve, something should start happening. We will get a new reservation, we will get a new billing payment processing. And if I will check this out to today and click reserve, then also the rental service should be starting rental for Alice. So everything works and we have our basic functionality. So remember, currently we have 10 containers, most of them running through dev services, plus 5 of our application JVMs, which are running in dev mode. Okay, so that would be the first step that we have in this image. Okay, that would be our final, and it's basically written here also. That would be our final semi-production environment, our local development machine. But if we want to put it to like real production, we shouldn't run dev modes. We should actually really run java-jar or compile it to native or put it into container and this kind of stuff. So I will purposely not do this because you will believe me that it's almost one-to-one and it just takes like a lot of time, just because we in real production, which we are going to put into the OpenShift at the end, we basically wanted to basically have like the most pleasant experience as possible. And unfortunately, Red Panda, for instance, isn't running that good in OpenShift. We decided to opt out for some like alternatives which will just perform better in OpenShift. And because of that, we did two small changes, and that's basically Keycloak is run in like production-like mode with its own Postgres database. So we are no longer keeping the user information in memory. We have it really in a separate Postgres on the side. And we also run Kafka no longer as Red Panda, but we are using something which is called Streamzy, which is originally Red Hat project, but now it's in IBM, which is just Apache Kafka distribution, which is tailored for like to run very nicely on OpenShift. And then back in January, this was still requiring its own version or its own instance of Zookeeper, which is a different container, which is doing orchestration, I believe. But actually, like 1 month, like I know that we already knew about it during the writing of the book. They actually included some alternatives which no longer need the Zookeeper container. But by the time at the of the writing of the book, that new technology was still experimental, so we decided to keep it here. So in the end, when you will run basically the infrastructure like this, you will run 12 containers just with these two additional. Otherwise, everything is exactly the same. And basically, all other services now needs to be adjusted. And I'm not going to write this. I will just really quickly go through individual changes, because so far everything was just like tailored really for development or for Quarkus dev. So we could use some shortcuts, like for instance, hard coding URLs to localhost. But when we are moving to cloud, it's no longer going to be localhost. So we need to basically make it configurable. And that's actually like the first like use case. So if we will start with the user service, I am not going to open it, but you might remember or you might check that we have these register as client annotations on every REST client that we basically used since chapter 4, I believe. And we hard coded the URL with this base URI parameter to whatever it needs to be, but it was localhost some port. This is no longer going to work. So one thing that we need to do is basically change that base URI to use so-called config key, which is just random string, which you can then use in your configuration to configure Quarkus.rest client dot your key reservations dot URL to whatever you want. So you see that we are basically configuring exactly the same URL as before, but what this will allow us to do is that when we are going to deploy in OpenShift, we can specify environment variable, capital Quarkus underscore capital rest underscore client, etc., etc., and we will override dynamically this configuration value just for the run inside the OpenShift, inside the pod in OpenShift. One thing that we are also should mention that this config key is optional. It's not required. You can actually hard code the full package name of your class. However, like this is not really scalable. If you will change the package or change the name of the class, you need to remember to change this. So this is just more cleaner solution, at least in my opinion. Oh my God, I didn't want to scroll. Sorry. So I'm going way, way ahead in this chapter. So we are back. So the other thing that we need to do, and we actually did this already when we were talking about Postgres, is to move the connection to Keycloak to basically have exactly the same thing. So we are just in prod mode overriding the authentication server URL and some other configuration, but this is exactly in the same way going to be overridden in OpenShift or in any other cloud. Yeah, this is the same thing for rental with register as client. And the last thing, of course, we need to configure the different connection to a database, which again is going to be run inside its own container, not as a dev service. But if you would, if you would check, these properties are more or less one-to-one to whatever the dev service for Postgres in this case will inject into your application. So like very often, I don't want to say always, you can just copy paste whatever is injected to basically make it your production or at least starting production configuration, because of course like dev services are not really production ready, but at least you will know that your Quarkus application in prod mode can connect to in this case Postgres if you will just copy paste that properties. Okay. Yeah. Actually, we are already in reservation service, and I didn't notice. So, like, you will like. Sorry, like I'm jumping all over the place, but like it doesn't matter. It is the same for all the services. Just this is done in reservation, not in users. The other thing that we need to configure in reservation is, of course, the connection to RabbitMQ, just a bunch of different properties. But again, you see everything which is defined like this is then overridable at runtime. The same thing with register as client. Now we are in rental client, and that's basically, yeah, REST client. The other way how to basically change the connection for Mongo, but more or less the same thing. Just for Mongo, it's okay to just change the connection string. You don't need username and password in the default. In inventory, one thing that we decided to opt in is to include this Morai GraphQL UI always include, because otherwise this /q/GraphQL UI is included only in dev mode. But since we don't have any other UI into inventory service, only this GraphQL UIs, then we decided to also include it in production. And relational database is exactly the same as before. But one exception, we also want to include this import SQL script also in production mode, because we have there like two cars that we are like preloading. However, this is disabled by default because, well, it's enabled only in dev mode because probably you don't want to really overwrite or like run some like testing development SQL when you will run your Quarkus application in production. However, in our case, it totally makes sense. Yeah, and in billing service, that's more or less fully reactive service, which just needs to connect to its own Mongo, to Kafka, which I probably overlooked in rental service, but it doesn't matter. You see, everything that we need is basically these Bootstrap servers, which is pointing again to localhost. And RabbitMQ is again the same as in reservation service, I believe. Yeah, that's more or less it. This is what I'm not going to show you because it will just take forever. So if I would run this Docker Compose with this Docker Compose infra YAML app, that will run that 12 containers as infrastructure in the background, and which reminds me that I can probably close these containers. So I will not forget about it. And basically, then in every chapter or every Quarkus service that we are using, you just need to package it and then run java -jar target Quarkus up Quarkus run -jar, and that will run it in production. It will pick all of these person properties, etc. And if you will all do all of this, which I described in the last 5 pages, it should run exactly the same. Just this time, you will have 17 content. Oh, yeah, 17 applications running, 12 containers plus 5 Acme rental applications. Just this will take forever and it isn't really giving like any real additional value. So I want to move to more interesting stuff, and that's building and pushing container images. In Quarkus, we have a bunch of, let's start from the beginning. So in chapter 2, we basically showed you that with every Quarkus application, you will directly get this main Docker, a bunch of Docker files, which you can directly use to compile any Quarkus application to either JVM, legacy jar native, or native micro. Even if you will just open any, probably need to do Vim, any of this file, you will see that you have the instructions how to do the compilation and how to build it into a container directly integrated, also how to run the container inside the Docker file. However, this is not so nice to like do it manually. Sorry, wrong workspace. So in Quarkus, you have actually a 5 so-called container building extensions, which are basically automating all of these builds in the background. And these 5 options that you have is either Jeep, which is technology, which you can read about, but I'm not going to dive into because we don't have time. We have normal Docker, which is just your install Docker, Podman, which is just using Podman in the backpack. In the background, and we have BuildPack, which is again different container building technology, which I'm again not purposely going to describe because it will just take time and it's like really not that important because we are going to use Docker. And the last one is OpenShift, which is using so-called source to image builds, which are very specific to OpenShift. And we will actually going to use that too when we will be deploying to OpenShift, so I will talk about it then. So when we want to build these basically images with Quarkus extensions, you don't actually need to manually add the extension to your Quarkus application. If you have Quarkus CLI, I think that this works only with the CLI, you can actually run just Quarkus image build and some of these options like Jeep, Docker, Podman, BuildPack, or OpenShift, and it will actually work. However, this doesn't really scale that much and it's not automating. It's just a really very quick way how you can basically test the functionality. And again, it will just take time, so I'm going to skip it, but it works. I tried it in the morning. So what I want to basically showcase is this manual adding of extensions, and we decided to use Docker. So we are just basically adding the extension to our application, and with that, I will actually close all of this. I will go to, which was the section? 11, 12, 2, 2, 11 to 2. So the 11 to 2. And we will go to inventory service because this is the one that we are going to use the most purposely because it only connects to MySQL. So it's the simplest service in terms of external dependencies. I can actually probably close at least one of these. We have a little bit of space. At least you can see all the time the very nice UI that took a long time to develop for our backend engineers. So inside this service, we should already have the Docker extension installed, and we don't because we are doing it in different service in this. Come on. In this one, yeah, so yeah, in this one. So, okay, sorry. For this section, we are still using reservation service, which I forgot. So we have this Docker extension already on the class path. And then when we want to basically build the image, all we need to do is either Quarkus image build or Maven clean package with this Quarkus container image build equals true property. If we want to also push the build image, then it's basically Quarkus image push or container image dot push, so not that build, that push. And you can also combine this in one basically run. I will just basically show you that if I just, if I copy paste the command, I will actually copy paste the Maven command because just I want some change. So if I run this, and of course you need to have Docker installed, I think that that goes without saying. More think because we don't have time for that. The tests should be passing. And as a really good engineer which is in a hurry, I can skip them because I'm sure that they are passing. So now after the build is finished, you can already see the logs coming from the actual executing the build image docker build blah 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 blah. So you see that the Docker extension is automatically executing my Docker build. It is actually using, and we can actually see it here, the Docker JVM file from that source and main Docker directory. So it's just automating the build from that Docker directory. But this is just this Docker extension. And if this is finished, we should see here that we built mstefan reservation service 1.100 snapshot. So if I do docker ps grep reservation blah blah blah, I'll try this reservation. Oh, not ps. Okay, images. Too tired. Then we see that basically it's here, I believe. Yeah, mstefan reservation service. And I thought that it will show also when it was built, but it doesn't matter. So we have our service. The one issue that is with this is that it will automatically pick up whatever your username is on your machine, the name of the application, and also the version of the application automatically. So if you want to push this kind of image and your username on your machine isn't aligned with your username in the external registry to which you want to push, then you cannot do that. So one thing which is important to do when you want to do this is to basically define some of these properties, these image customization properties. So either container image registry, group name, tag, or image, which can just combine all that four together. And this image will actually take precedence, I believe. There is a bunch of different stuff that you can configure, but these are the mains. And basically this is what we need to actually change when we want to deploy to, in my case, Quay.io, which is the registry which I'm going to deploy to. So here in 11.2.4, we are actually going to move to the inventory service, and we are actually going to add this property. So let me switch to that chapter, which was 11 to 4, I believe, inventory service. And let me open it in IDEA so we see it a little bit more nicely. Come on. Come on, IDEA. Come on, computer, be faster. I don't have that much time. This is not a complex project. So here we basically already added this container image registry to point to Quay.io, which is just a different alternative to Docker Hub if you are not familiar with it, which is run by Red Hat. Okay. Then basically we are specifying the group, which is your username or organization ID into which you are going to push. I will actually change this because I don't really want to repush the images that I pushed for the book. So I will change this to my username on Quay.io, and then you can also specify some text. So just because I want to showcase this, I will change it to 999 snapshot. And then basically, let me copy the command from the book. If I will run this very long Maven command, of course, you need to first Docker login into your registry, but I should be already logged in, so I am good. Then I can basically just run maven clean package with Quarkus container image build through, Quarkus container image push through, and of course, all of these properties here are also overridable with system properties on command line. So if you, for some reason, need to push to different organization, it's just -d Quarkus container image dot group, whatever your organization AD is. But if, because like I have this correctly hard coded here, we should see that now, and nobody told me, but like save time, save time saver. This should be -d time saver. So come on, still building the jar. Now we are building the Docker container, and you should actually see that it should tag quay.io xtefunk inventory service 999 snapshot. So at the end, we should see that it built exactly the same image. And because unfortunately copy pasting from the book is doing a new line where it should not, then I need to run it again because it basically didn't take the last property just because it was on a new line. So let's do it again. And we are still good in time. So I should have enough time. So now I'm just rebuilding the same image, and you see that after it is finished, it is pushing basically that same image to quay.io. And because it is now aligned to my username on quay.io, I should be able to go to quay.io. This is my user account. And if I check last modified, I see xtefunk inventory service, and if I go into text, I should see 999 snapshot, which was modified a few seconds ago. So you see that I just basically pushed the image automatically from my command line with a single command. And this is how you can basically automate the building and pushing of your images to any registry that you want. So that would be more or less that I want to show, just because again it would take forever to do this for all the 5 services, because they are already configured and ready for the deployment into clouds. We just basically need to push the images to some registry which is accessible from the cloud, which is usually not your machine, or it shouldn't be your machine. So because of that, I created Quarkus in Action organization, which has all of these 5 images already pushed. You see, it was done last year for the book. So you can actually use this right away. This is just hard coded with Quarkus 3.15.1, but if you want, this is how you can push your own images, and it's actually also in the book. So if you want, you can push it yourself. Then if we have everything running, and I don't think that I need to run it because it will just take like a bunch of like a few minutes to just get it running. But we have a one big Docker Compose rental YAML, which is just a Docker Compose file that is putting all of that 12 infrastructure containers that we used to have for the local production environment. And it will just add these quay.io Quarkus in Action user services on top of that. So you will see all of our 5, and the last one is here, 5 services adding on top of it, and you can verify on your own that it will still work. So this is already the full production system running with a single command as in Docker Compose. However, this is still only local on your machine, and what we really want to do is push this to cloud. And for cloud, at least in my opinion, when we say cloud, that is more or less synonym to Kubernetes, because you can, of course, use the proprietary platform APIs of probably like the biggest free public clouds. However, Kubernetes is de facto standard, which is unifying the deployment model throughout all of these environments. So usually, at least in my experience, our customers tend to use Kubernetes or some flavor of Kubernetes, because if you don't know, Kubernetes has been forked more than 50 times. So there is a lot of versions of Kubernetes, but the one that I prefer the most is OpenShift, because this is just more solid standalone like application development model, also from somebody who is not like full operational engineer. So you have a nice UI, and you can also click configure a lot of stuff. It will give you a lot of even objects on top of the basic Kubernetes, which will just ease a lot of stuff, like for instance the route, which if you know how you if you are working with Kubernetes, configuring ingresses or like load balancers and like exposing your application outside of the cluster is like not so easy. In OpenShift, all I need to do is click a button or just do OC expose some service, and I will get external route into my clusters, which is extremely nice to use. And also one benefit is that OpenShift, because it's one of the main platforms done by Red Hat, will there is this project which is called OpenShift Sandbox, which is testing environment for OpenShift. So basically, anyone can subscribe to Red Hat developer subscription, which is totally free without any payment information required. And you will get OpenShift cluster, single node OpenShift cluster available for 30 days, where you can basically play as much as you want, which is exactly what is enough for us in this book or in this scenario. So I can give you free OpenShift. I cannot give you free Kubernetes. So this is why we are going to use the OpenShift inside the book. Okay. So Kubernetes and OpenShift are, at least from Quarkus point of view, very similar in use. So we will purposely, again, because we don't have time, I will not show you everything, but we have everything covered inside the chapter. Typically, all of these extensions, and one more, which I forgot to say, is Quarkus Knative. Knative is a project which is used for serverless deployments. We have actually a separate section about this later. But all of these, Kubernetes, OpenShift, and Knative, are configured in a very similar way. Typically, Quarkus.Kubernetes or Quarkus.OpenShift and similar, Quarkus.Knative. And you can specify basically anything that will come to your mind, because I didn't mention, but all of these free extensions are using this library which is called Decorate, which is just basically the library which is able to generate the Kubernetes manifest based on your Java application code, typically configured by annotations. But you can change all of these, or like most of the options, or how the actual manifests are generated, through either the annotations or how you are like creating the objects or classes, structuring the classes in your application, or you have configuration properties. And there are like so many of these Quarkus.Kubernetes. If you will check the all config, which we have actually somewhere link here to all config, but I will not do it here, that you can change, that we don't really need to dive into. One thing that I will mention is that, because we are going to actually use it, is this is how you will configure the environment variables for the deployment. And you see this is quarkus.kubernetes.env.varfs, then the name of the property, which is actually the actual name which is going to be included inside the pod in our case, and then equals environment variable value. This is something which we are actually going to use in our deployment. Okay, so deploying Quarkus application on Kubernetes, I have actually, I think, Minikube running locally on my machine, but this is just like taking some time. So I will just go really quickly through it, because we don't really need to showcase it. You can try it on your own if you want. But all you need to do, Quarkus extension at Kubernetes. Then when you will run the build, this will actually already generate the manifest out of the box for you. And we have actually that manifest prepared inside the book, because it's just too long. And I think this is in Kubernetes default YAML. So this is actually the default generated Kubernetes manifest that we took from inventory service. So you see, for instance, automatically added Quarkus version, the name of the application inventory service. It will automatically detect or it automatically detects the extensions will actually tell the decorate which ports are exposed from your application. So you see that, for instance, our manage, because inventory service runs on port 8083. This is done by Quarkus HTTP port. So you see that it automatically configures mapping from port 80 to 8083 where your application is running. But it also detects that we have a gRPC server exposed from inventory service. So it will also do the same for port 9000. So this is why we can also connect to GraphQL UI. So this is the service which is created. We have also deployment. Like, for instance, like it automatically can detect that we have metrics on our application, but I don't really think that I need to go into details. But what I want to show you is that it will also automatically find that properties that we configured for the image that we are pushing, and it will automatically pick that too. So you see that we have that Quay.io Quarkus in action inventory service, because like in the book, I didn't change it to xdefunc. But like in my case, if I would do this for my application, it would be like Quay.io/xdefunc. So this is extremely useful, because what you can use it for is automatically push the image and basically just redeploy everything on Kubernetes in a single step. And this is actually something which the extension can actually do for you. But the last thing that I want to show is, because we have Small Health extension, it will also automatically configure the liveness and readiness or startup health checks for you. You see that it's on correct port, on correct paths, which is quite nice to be generated out of the box. And this is not important service monitor, it's just some Prometheus stuff. Then if you have this manifest, all you can basically directly take it, because we know that we already have the image pushed, and just do kubectl apply -f to your like target Kubernetes YAML. It will also generate Kubernetes JSON, which is just the same stuff, just in JSON. But YAML is more popular in Kubernetes, so we stuck with it. This is not so important. Yeah, one thing that we need to change when we are going, because as I mentioned, inventory service depends on MySQL. So we actually have also this kubectl Kubernetes MySQL YAML here, which is just a very simple deployment of MySQL, like real production image of MySQL. But because we need to basically deploy that together with our inventory service application, we are utilizing one other feature of this Kubernetes extension, and that is that if you put something to where is the bot? Where is the bot? Oh shit. Sorry, I forgot that I cannot scroll this application. Not serverless, that's too far. Where is it? So okay, I will find it probably later, but like before that, we know that we have like hard coded MySQL URL to localhost 3300. So one thing that we need to change when we are going to Kubernetes is to add this Quarkus Kubernetes envars Quarkus data source JDBC URL, which you see it's exactly the same Quarkus data source JDBC URL as we have here. Just this will be included as environment property, and we will point it to MySQL 3306, which is the name of the service or the URL which will be actually exposed inside the Kubernetes platform. So this is not that important. Yeah, and it's here behind Mateus's face. You don't see. I need to put you into different corner.
Just cross that.
Sorry?
You can cross the window here.
I can close this window. I will not disconnect.
Yes.
You can still hear me. Okay, perfect.
Yes.
It's better.
So yeah, now I can see the full book. So this is actually what I was talking about. So if you put any file to Saracen main Kubernetes, which is named Kubernetes YAML, so not any file, it needs to be Kubernetes YAML, it will be automatically copied to whatever decorate will generate. So if we will, come on, why am I scrolling? I didn't scroll this time. Come on, where am I? So if I copy paste this MySQL YAML into this main Kubernetes YAML, whatever I will build, and I will actually show you this if I will know in which section I am. Yeah, 11.3.3, 11.3.3 into inventory service. And if I just do really quickly, and let me do it fast, very quick build, so we will get that actually manifest generated. Come on. Come on. Be faster. So now in target Kubernetes, I should have this Kubernetes YAML and Kubernetes JSON. So if I open that Kubernetes JSON, you will see that MySQL is actually copy paste before my actual this is still deployment MySQL before my deployment, which was generated by the decorate. So it will just like combine them both. And now I have everything inside a single manifest. If I will, because you will not believe me, of course, serves main Kubernetes YAML, you will see that it's exactly that MySQL YAML, which is just really copy paste. So this is how you can basically, as in my case, set up some infrastructure which you need to be, which you need to have deployed together with your main application. Then basically you can directly take whatever is generated and just kubectl apply target Kubernetes YAML, and it will work. So I am not purposely going to do that because it will just take some time, but I want to just mention that you can also combine all of these steps because we still need to build the application to generate that Kubernetes YAML in target Kubernetes, and we need to manually apply it. So you can actually combine that and just put this single property, Quarkus Kubernetes deploy true, and Quarkus will do all of this in the background for you. So it will basically package your application, build the image, push the image to your registry, and kubectl apply the manifest so your new version of your image is automatically applied in your Kubernetes platform. It takes some time, but it works. So this is why I'm not showing you. It would be actually a really cool moment, but like purposely because we don't have time and I want to still deploy the full book to OpenShift, I'm just keeping that. Okay, so moving on, OpenShift. Almost one-to-one. So we just basically need to remove the Kubernetes and just add OpenShift extension. We need to also specify this Quarkus container image builder extension because you remember OpenShift is actually also container image builder extension. So it will actually fight with Docker if you have both on the class path. So if you want to build with Docker, you need to manually specify this on command line when you are doing container image build or push. But other than that, it will generate, again, the OpenShift YAML, OpenShift JSON in target. You can also include certain main Kubernetes. I think it's still Kubernetes, but like certain main Kubernetes, the file needs to be named OpenShift YAML in this case, but I think like Kubernetes is still in there. It will just generate a bunch of more stuff. It will still generate the same stuff as Kubernetes, but it will, for instance, also generate this image stream, which is a custom object in OpenShift just to use to version your images inside the OpenShift platform. It will also generate this build config, which is actually the configuration to do that source to image builds, which I will describe in a moment, which is going to produce some inventory service images, as you can see here, based on OpenJDK 21, but it doesn't matter. You can read through this inside the book because it's just, again, I scrolled somehow. I have no idea how much I'm scrolling with the touchpad, but at least we are getting to the end. So I think that I should be able to do this in 10 minutes, but I will probably not deploy everything. And actually, this is where we are going to describe the source to image build. So source to image is basically, again, concept available only in OpenShift, which is doing these four things. We will basically build the jar locally on our machine. We will then push the jar to OpenShift. OpenShift builds the Docker image inside the OpenShift. and it will automatically rerun or redeploy the deployment, which is the actual runnable declarative instance of your application in OpenShift with that image that it just built. So OpenShift is keeping its own registry, and basically we don't need to even have the Docker locally installed. We can basically do that source to image inside the OpenShift itself, which is, in my opinion, extremely nice, because basically you are moving the whole operational part of development of your application to the platform where you are deploying, and your local environment basically ends on building the jar, which is exactly the same thing which you are doing when you are just running the tests. So in my case, this is like the nicest and cleanest solution, but of course it's not for everybody. So we again need to basically override a bunch of environments, but this is more or less the same, just Quarkus OpenShift, not Quarkus Kubernetes. And yeah, it needs to be Cerezo main Kubernetes still. So this is a hard-coded path. So that file needs to be named now OpenShift YAML, but it still needs to be in Cerezo main Kubernetes. This is the only mention, I think, of Kubernetes that is left over. Then basically we will get again target Kubernetes. Okay, so one more mention of Kubernetes, target Kubernetes OpenShift YAML when we build the application, and we can again OC apply it directly to a platform. And I actually can show you this because, oh, I will probably not show this one. I will show you that OCI build. So if we go into inventory service, I will just quickly build it. So I have that application generated. And if I go to Red Hat OpenShift Sandbox, which I should have running. So this is just really public site which you can sign up yourself. And of course, I'm not logged in. Hopefully I can log in. So OpenShift, and I should get my cluster running now. Come on. Now we are getting into my internet speeds, which are not totally fine. So like we will need to delete it. This is already OpenShift. I can check what I have there with this topology view. And I hope that, yes, I deleted everything. So now I have my mstefan dev namespace, which is totally empty. If I want to log in into this OpenShift, this is also described in the book. I need to copy this login command. And then in my OpenShift, I can just paste this, and I am already logged into my OpenShift. So it should be empty. But I can now OC apply -f target Kubernetes OpenShift YAML, and this should be already running the Quarkus in action inventory service 1.0.1.1001 version of my application. So if I go back here, we should get our two services. One is MySQL running, which should be already healthy and running, and it is now. And our applications need to be probably restarted a few times. Oh, come on, image pulled back off. So like the image is not correct. No, it seems to be correct. So what is wrong? Is run the application.
Should it be snapshot?
Well, actually, I'm not sure. I don't think so. Let me check the inventory service. No, it should not. I wonder if I didn't change it in my testing. So let me do really quickly search some main resources, application properties. Oh no, I know what the issue is. This is one of the problems that I ran into when I was developing the application, and Actually, yes, this is part of the issue, because inside the book you will find that we have this like Quarkus container image tag also specified, because otherwise it will pick the version of the application which is actually snapshot, which we don't want to. But because somebody changed Quarkus and they made this Quarkus container image tag property mandatory, this this solution which I had here to basically in this source to image profile remove those properties, which is registry group, and it was also the tag, stopped working because that tag is actually mandatory. So if I want to run source to image build, and let me do that because this was a fail, which I forgot that it will happen. I'll see, delete all. So now, because this doesn't work, and inside the book you will find that you can run the source to image basically just by specifying quarkus.profile equals s2i. You remember that you can define your custom profiles with the percent whatever string. So we have this default %dev, %prod, %test, but you can define your own. So if you would say Quarkus profile s2i, that would actually unset these properties. But because somebody changed that tag to be mandatory, this stopped working. But this is one of the things that I want to fix. But if I now just run maven clean package -the skip test and Quarkus OpenShift deploy true, this will actually run that S2I build right now. Oh, well, probably I need to still specify that. Let me copy paste the command from the book because I don't want to make some mistakes. So here you have it. So I will specify Quarkus profile to be prot and S2I, but unfortunately this needs this small addition now, because by the time in the book it was working with just like unsetting, but this is something which we can fix. Because unfortunately I had to upgrade Quarkus version because OpenShift is no longer like supporting the same client versions. But it's like not a biggie. But like here we can already see that source to image build. These logs are actually already coming from OpenShift. And if I go into OpenShift and go into builds, build configs, we should see actually our source to image build already being run inside the OpenShift. And if I go into logs, you will see, if my internet is fast enough, I hope it is, that is receiving source from std archive, now copying some blobs, and you will see that this is exactly the same logs which are actually pushed from OpenShift to my local terminal right now. So we will wait for this to finish, but now we are running into that problem with the speeds of my internet at my home. You see the actual Docker build which is being run there inside the OpenShift, because this is no longer running on my machine. This is everything done inside OpenShift. You see, hopefully, that is pushing image to some registry inside OpenShift to my namespace, etc., which is called inventory service. And if this was successful, it should automatically deploy my application into the namespace, into my namespace, and hopefully this time it will find the container because it was just built inside OpenShift. So if we will give it a little bit of time, because it needs to still pull it, now it's running, and if we check the logs, come on, yeah, our application is running on OpenShift.
Great.
Thank you. That's good. We have running demo. So because we also included this main resources application. Come on. because we also included this Quarkus OpenShift route expose, it will automatically give us this arrow. So it will actually automatically exposes our application. It will create the route object for us in the background. And we can just click this button and yeah, this is expected error. Because I need to go to HTTP, blah, 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 GraphQL UI. And if everything works, this is GraphQL UI already running in OpenShift and connecting to our MySQL inside the OpenShift. So it works. So this is the easiest way how you can deploy your application to OpenShift. And basically, like I would probably park it here because now the only thing, well, there are actually two things, but I don't really want to take this too much over the time. So I will just go really quickly through. Yeah, we have also mentioned of Kubernetes and OpenShift clients, but this is not that important. It's just like programmatic API to the clients. But I want to really quickly showcase this serverless application with Quarkus, but because we basically more or less for the real production environment, we are actually showcasing either the manual deployment with OC apply -f, but we are also showcasing the full deployment with this source to image. But it's more or less the exactly same thing which we did in this inventory service, just in all that other 4 services. So I will purposely go a little bit to the end of this chapter because somewhere here, yes, I want to copy paste this command, which is just basically taking all of our images with all of their infra and deploying everything to OpenShift. I will just OC delete everything here. And because this will take some time to run, I will talk through the rest of the chapter through serverless while this is deploying. Come on. So let me just quickly run this very nice command, which you will see that it will run a bunch of stuff, a lot of stuff. Actually, that OpenShift, that car rental full YAML is over like I think 3,000 or 4,000 lines, but it will run everything that we need inside this book, and it's actually more stuff that I remember. So it's still creating some stuff. Okay, that's a lot of stuff. Okay, but if this will be successful, this will be everything that it will put together. So our 5 Acme car rental services plus, I believe, 17 containers with our infra. But let OpenShift fight through this. You see that it's creating already everything, and I cannot scroll it. I can't scroll it. So actually, it's already running most of the stuff, but let's give it time. And let's very quickly go through serverless deployment, which I will be not showing because I don't have time, but I just want to quickly talk about it. So serverless application development, I will not describe. I believe everybody already heard about it. So it's a way how you can like automatically auto scale your application up or down in terms of instances. In Quarkus, there are like several options that you can use as a technology for this auto scaling, but in book we opted to use Knative, which is a CNCF project, which is one of the like most popular in this area. However, because there is a bunch of like alternatives like AWS Lambda, Google Functions, and etc., which are having slightly different APIs for this. In Quarkus, we created this special extension, which is called Funky, which is basically a unification of all of these different approaches. So in Funky, you have this one annotation called @func, which you can put on like not any method, but on a method with some like predefined signatures, but it can take like any POJOs, for instance. So it's like not that it's like totally plain, but it will basically denote this method as a function. And basically, it will automatically generate the individual descriptors or deployment models for these different platforms. So it's from your perspective, you will just write your function as a normal Java method, and Funky will take the care of everything else. So after you will have this, we will actually like in the book create a new car statistic application, which you can where we will basically add that Knative extension well, Knative is actually automatically included in OpenShift, but it doesn't matter. But you will see this deployment target is Knative. Bunch of different stuff which I will skip. We will just basically integrate GraphQL client in this car statistics application to call inventory service, GraphQL server, to basically get some statistics, which is in our case just the number of cars. It's not that important, but we have this add func annotation. You see that it can also do reactive stuff. And we will just call the inventory client to get all the cars and just print something to a console. It's not that important. You can verify that it's running also inside the dev mode, but it's like not that interesting. But when you will package your application, optionally again, Quarkus Knative deploy, however, it will again generate the manifest, and you can also apply those manifests automatically. If you are using Red Hat Sandbox, Knative is automatically installed in there. But if you are using any other OpenShift or Kubernetes, you need to install that Knative platform on top of it. It's usually a bunch of so-called Kubernetes operators. So it's like pods which are managing your resources. So it's nothing like magical, but you don't want to really do this on your own. So in this sandbox, it is automatically installed. So I can just Maven clean package with this Quarkus Knative deploy, and it will basically do exactly the same thing as OpenShift deploy through. It will do everything in the background. And in the end, I have or in the background in the OpenShift. And in the end, I have a running auto-scaled serverless application deployed in Quarkus. Of course, you can take it one step further, and because Quarkus is very easy to deploy to native code with GraalVM, you can just add to this command, where was it? Maven clean package, blah, 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 minus the native or minus p native, and it will do exactly the same thing. Also, the S2I build inside the OpenShift, just with your native image, not with your jar, which will be even faster. And in this case, if you remember, this is one of the use cases that I basically told you back in chapter 2, that it actually makes sense to compile to native, because your serverless can run into this basically, like the whole point of serverless is that it should be scaled to 0 if there is no use of your application. But if somebody calls your application need to actually start to handle that request. And that start time is actually added to the time of the request. So basically, when you are writing serverless applications, there is a requirement for them to start fast. And this is where the native actually makes sense, because typically, if nobody calls that application again, like in my case, that car statistics can be called like every week or every month, basically it will never run longer than, I think, by default 1 minute with Knative. So if nobody calls it again in 1 minute, it will again scale to 0. So we will call that instance, which is perfect use case for GraalVM and native compilation. So when you have your application, you can just basically call it on a route exactly in the same way. This is how it will look like in OpenShift. I really don't have time to showcase this, but when you will not call it in 1 minute, you will see that it auto scales to 0. And if you find a way how to call it in parallel very quickly in succession, you will see that it will automatically scale to more than one pod when you have like multiple requests, which is not able to handle. So that would be more or less it. I can showcase all of this running on my machine. I actually tried it today. However, it will take time. So we don't really need to spend another hour here to showcase everything that I have. And the last section is more or less deploying everything to Sandbox. So you will either, this is showing how you can log into Sandbox. So you will either basically use S2I, as you can see, that was that container image tag, which is no longer there. And you can optionally, where is it? Yeah, this is just like environment variables, which we need to configure for OpenShift, but this is like the same stuff that we did for local Docker, just putting it into environment properties. And where is it? Yes. So then basically you need to go into every directory and either run that as like push your own image. And yeah, then you can OC apply all the generated manifests. We actually or yeah, we have like scripts which are just doing this in the background. So you have S2I and you have OC, which will just do like this. S2I will just do minus the Quarkus profile S2I and Quarkus OpenShift deploy through. OC will do just Maven clean package and OC apply target Kubernetes OpenShift YAML. But in the end, whatever you will do out of these two, you will end up with all the application deployed. But what I did will just do like the whole deployment in a single file. So this is like really OC apply more way of things. And if everything was deployed correctly, if I will find user service and I click this button, hopefully it will redirect me to Keycloak running inside my OpenShift. And if I log in, come on, this will take a little bit of time because now we are inside the cloud. I should be able to reserve my car and let's do today to update reserve. And if I go back into, let's say, billing service receipt here and check the logs, I should actually see that some invoices has been processed for user Alice and start date 4 and start date 3. So we see that our application is fully functional and running, where am I going? And running in cloud. And I will not spend time into putting this into a nice arrangement as I did inside the book. This is actually something which took a lot of time to align it very nicely. But you see that we are basically done, and this is the end of the chapter and the end of our Acme car rental. And next week, there is this optional writing your own extension part. So yeah, more or less, this is what I wanted to showcase today.
More or less. Congratulations. Everything works expected.
I'm actually very happy
Okay.
that it works because like there is like so much stuff that can go wrong when you are deploying
Yes,
this.
on deployment, so much stuff go wrong.
Yeah.
So I'm very
Okay.
happy that the demo works.
Great chapter. And the next week, we will have. I'm not sure. I don't know if in your location is holiday or not.
Not yet,
But
but
yeah,
it depends. It depends if we want to finish because like this is like really more advanced stuff, and I'm not sure if that would be interesting enough to people because like writing your own extension is not something which is like typical day to day. It's a really more advanced use case for people that really want to push Quarkus to some specific use case, and like let's put it this way, we can talk about it. It will definitely help you to understand how Quarkus is put together, but like I'm not sure like how much it's interesting in general. It's like really internals of the library, more or less.
for people that want to learn more about Quarkus, what's the things happen in behind the scenes, it's okay. It's a great chapter.
Okay,
And
then
okay,
I would
let's
say next
decide.
week. Yeah,
Next week,
next week
okay.
then.
Then next week, let's learn more about Quarkus extensions. What is Quarkus extension? What is build items, build steps, and everything. I don't know if everything, but the the, the core
Definitely
part.
everything.
Definitely not everything. Okay, but
we,
okay.
we will we
See you in
will
the
we
next.
will always scratch the surface. Like writing Quarkus is very complex. Like if you want to touch everything, but you will at least learn how to start if you decide to write your own extension.
Yes, yes.
Great. Thanks. Okay. See you next week. Thanks again,
Okay,
Martin and Marceline, to stay here. And bye bye.
thank you. Bye.